Good morning, students. In my last class, we have learned about rigid and elastic systems and the discrete and continuous systems. Today, we'll be discussing about degree of freedom, and later then we'll cover the constraint motion and holonomic, non-holonomic constraints. But we'll start today's discussion with the introduction of how degree of freedoms are available in motion and how it can be looked into to solve different problems and how it can be useful. So I hope you are seeing the screen, and let me extend it. Yes. So we are into module 1, the second part of module 1, and this is the third part of this lecture. Um, we have already covered few things like we have discussed the discrete and continuous system and rigid and elastic bodies. So our main focus with today's class will be degree of freedom and how it works. So myself, Dr. Pradeep Sharma from University of Engineering and Management. Again, request you to note down the contact number and email ID in case of you have any problem or any doubt. So you can directly write to me any message or email as per the problem what you are facing. So I will be trying to sort out in the minimum time if possible. So constrained motion, if we say, then we must understand that every motion is restricted by certain conditions. So in a motion of a particle or a system of particle, if there are certain conditions which are controlling the motion, for example, suppose I am just putting one example here. See, the cap of this pen, outside, when it is not attached to the pen, we can take anywhere, right? But when we are putting this cap on this pen, its motion is restricted by certain conditions, that it will move only in the direction of the length of this cap, so that it can fit it. So in every motion, there are certain conditions governed by the environment or certain parameters or some physical restrictions are there, so that their motion is controlled. So these limitations on the motion of a system are actually known as constraints. Okay, and such motion is called constrained motion. Now there are a few type of constrained motion, like completely constrained motion, incompletely constrained motion, and successfully constrained motion. So what is completely constrained motion? That we have to understand. So one by one I am just trying to see that if the motion is between, suppose an object is there, but the motion between those pairs is limited to a definite direction, irrespective of the direction of the force applied. Whatsoever the force we will apply, that object will move into that direction only in which he is fitting into, right? Like this pen example I have given you. If I am fitting on this cap on this pen, whatsoever the direction of the force will be, the motion of this cap on the pen will be only in this direction, right? So that kind of restrictions are available, that we can put in completely constrained motion. For example, the motion of a square bar in a square hole, as here in the figure. So this is the square hole put and a square bar is being put over there. So this square bar can only move to and fro, means in this direction. It cannot rotate, right? Because it is being confined with that shape of the, you can say, the cage, the hole. Accordingly, it can move, right? So like that, this is the completely constrained motion. So restrictions are available, but the motion is possible, but uh, you can say limited to a definite directions. Now, incompletely constrained motion can be when there are links not confined to a definite direction, but it is you can say like a circular hole and a shaft being put. So you can understand that if the circular hole is available, so the shaft can rotate also and shaft can move in this direction. So this type of motion is known as incompletely constrained motion, and but definitely this is restricted by in this direction because shaft cannot move here and there, but the shaft can move to and fro as well as shaft can rotate. Now the third one is successfully constrained motion, where you can understand that motion in definite direction is not brought about by itself, but by some other things. So it is known as successfully constrained motion. So by itself, the object cannot move, cannot rotate, but the, you can say, second object is available by other means that our primary object can move. For example, foot step bearing like this, and you can say that the foot step bearing is actually having this load and a shaft. So this can take the load, but it can move only when the foot step been there. So it depends on the action of this foot step. Okay. So that type of foot step bearing is available. So if the load and shaft is there, so accordingly it can move, otherwise it will not move, it will not have the motion. So three types of constrained motion we have seen. The constrained motion, what we have come up to, that there are certain restrictions due to which the object can, object motion can be controlled, and the motion in one direction or the other can be seen into accordingly. Now, according to the directions available and the possibility of the movement of that object, we can now define the parameter, the very important parameter, which is known as degree of freedom. And these are the minimum number of independent variables or coordinates required to specify the position of a dynamic system. So you must understand that here minimum number of independent variables or coordinates required to specify the position of a dynamic system. So these things you must identify. Now the condition is without violating any constraint applied on that. The configuration of n free particles has 3n number of degree of freedom as per their 3n dimensional space, because if one particle is available, so there are 3 directions available, so there will be 3 dimensional space available to that. So one particle can move in, you can say, in those 3 directions, but if n number of free particles are available, so those n number of free particles can move in you can understand like 3n is space, so that is known as configuration space of that system. So how many number of particles are available, accordingly we can identify the configuration space. And the number of coordinates required to specify a dynamical system becomes less when any constraint work on that system, because suppose we are restricting the motion of a particle in x direction, particle cannot move in x direction, though x direction is available, but that cannot move. So there are only y and z directions are available. So there are restrictions, and accordingly the degree of freedom is reduced. So we can define degree of freedom of dynamical system as the minimum number of independent coordinates required. So you must understand that this is an important part, like degree of freedom of dynamical system as the minimum number of independent coordinates or parameters required to specify the system with constants. So, and if n free particle has m number of constants, so we will be having the independent coordinates will be 3n minus m. So I hope you can easily understand that 3n is the total number of available spaces, available coordinates, available parameters in which particle can move, and small m is the restrictions available. So accordingly, the total number of free spaces are reduced. For example, a particle in space, degree of freedom is 3, right? And for any particle in a plane, it has 2 degrees of freedom because the third parameter is being restricted. So accordingly, 3 minus 1 is 2. But for any particle moving on the spherical system, so degree of freedom is 2 as the constraint is 1, because on the spherical system it cannot increase or decrease its radius. So for that the restriction is available on the distance of that particle from the center. We can understand this part in an important manner, like if we are available, if the particle is here, so where it can move. So particle can go up and down, left or right, backward and forward. Now it can roll also, it can take a pitch, and it can take a yaw. So I have to identify what all these things are. So let me explain you with one example. Just a moment. Yes. So I hope you are seeing this pen. So if I am taking this as so this pen is there. So if we consider this as an object, so if the motion being considered, if it can move right and left like this, it can move this way, it can move this way, it can move this way, right? So this is a simple motion. Okay, so what it is doing, it is moving like this in the direction of its length, it is moving like this in the direction of its width, it is moving like this in the direction of its height, but it can roll also. Keeping the same position, it is changing its angle of rotation, so it can roll, right? So this rolling, right? I hope you are seeing, and it can move in this way also, this way. Okay, it can move in this way also, right? So all these motions are possible. So when we are considering this, you can understand that when we are considering this, so this type of motions we can easily understand. Another point, let me start with the presentation. Yes. I hope you are seeing this again. Already we have seen this, and then we can understand that if a particle is at the center, it has three translational degree of freedom, like this, and movement, and two rotational degree of freedom. One is like this, and one is like this. Okay, so two rotational degree of freedom. Now, if we see the translational movement in three perpendicular axes, so it can be taken as surge, moving forward and backward. It can take heave, moving up and down, and it can sway, moving left and right. Okay, you kindly consider this is the translation movement in three perpendicular axes, like surge, moving forward and backward is surge, moving up and down is heave, and moving left and right is sway. And in addition, there are rotational movement about three perpendicular axes. Okay, so if you can say rotational movement in this direction, rotational movement in this direction, rotational movement in this direction, and then in this direction. So you can understand that if the rotational movement is like this, it is available here. Okay, so if you keep on this direction, it is rolling, right? If it is moving rotational movement at there, it is pitch, and that axis is pitch, and if it is like this, it is yaw. So you can see rolling is tilting side to side, pitch is tilting forward and backward, and yaw is turning left and right. So this way you can understand there will be 6 degrees of freedom available. 3 for surge, heave, sway. There is no rotation available here. So 3 degrees of freedom here, and 3 degrees of freedom for rolling, this and here. Right. So this way we can make out, and for human body again, this if we consider up down axis, side to side axis, and front back axis. So we are having a transverse plane, we are having a frontal plane, and we are having a sagittal plane. And accordingly, we can define movement along an axis, 3 degrees of freedom. So along the side to side axis, sway side towards away, along the front back axis, and along the up down axis. So we can understand over here. So it can take like this, and like that movement. So that kind of movement along the 3 axes are available, and because it is a linear movement, so this distance can be measured in inches, feet, or meters as the unit of distance. Okay, but if we rotate standing over there, so again 3 degrees of freedom are available. If it moves around the side to side axis, bend forward, backward, then around the front back side, side bend tail side, like this, and around the up down axis, open closed. Okay, so angle, because it's an angle, okay. So these are degree, radians, and unit you can use. So in the same manner, so we will be having 6 degrees of freedom, and in the same manner in our hand, if you see here, so how you can move your hand. So if you see your finger is available to move only in this movement, right? this or this. It can rotate. It cannot rotate here. So you can rotate from here, but not a finger you can rotate. Okay. Same with this finger, same with this, and all the fingers, right? But over here, at this point here, so this is available and this is available. Rotation is available and this is available, and you can see this type of movement is available. So this is available, you can see here, this is available and this is available, right? This is available, this is, but you cannot rotate. Okay, but see here at this point, so this is available, this is available, this is also available, right? So this way, if you can consider, so at this point we are having 6 degrees of freedom. It can go in any direction, any type of motion, but at this green point we are having 2 degrees of freedom, because in 2 directions only we can move. But in this joints of our fingers, we cannot move in more than one direction, so only 1 degree of freedom is available. So it's, I think, very easy to understand how degree of freedom is working. So again, we can see here, this is the rolling in one axis, this is yaw, and this is pitch. Okay, and if we see this here with example of plane. So rolling when the plane is actually taking the complete revolution about its axis passing through its length, and the pitch when it is moving about its one wing, and yawing is when it is rotating like this. In air, when it is moving, so these type of rolling, pitch and yaw can take place. So you can understand here by 3 different pictures. This is the pitch when entire plane is rotating, and this is yaw when it is side by side rotating, and rolling when it is rotating around that axis passing through its length. So 3 degrees of freedom we again can have if we are measuring that total head rotation and tracking or activate with pitch, yaw and rolling XYZ axis, and there is no depth in the room. But in 6 degrees of freedom tracking, head rotation tracking are accurate, and positions or body movement, because you can understand that these type of things now are taking place in virtual reality, where we are designing the games, different games in virtual reality, and we are fixing the sensors to see the movement, the head movement, the hand movement, or the body movement of the participants there. And I hope you have seen that whenever a video or whenever a game is being developed, software is developed, so it is actually taking care of the movement. Let me show you once again. If a bot is there, so if it is moving here and there, like in this direction, it is sway, but if it is moving ahead and backward, then it is surge, and if it is moving up and down, then it is heave. And if it is moving like this, then it is pitch. Like this, it is rolling, and then yaw. Okay, so you can take that it's from the front actually, so it's from the front if it is rolling. So I hope all 6 things you are now clear: sway, surge, heave, pitch, roll and yaw. You can take care of this properly. Now I can again show you that how in development of a game you can see the 3 degree of freedoms can be tracked by goggles. The goggles being there and the sensor is available. So if we are having a goggle and we move here and there, and according to the head movement, like that, like that, like this, the sensor actually governs the 3 degree of freedom. So this is pitch, rolling, and yaw. So a sensor is there. If movement being taken care of, forward like this, left to right, and up and down. Okay. So these kind of movements can be taken care by another sensor, the external sensor. So these type of pitch, roll, and yaw can be calculated using a goggle attached to the object, because it is here like that. But an external sensor is required if we are moving, if we are changing the position like this or backward, forward. You can understand that these type of things are important, and as you see that yawning and rolling and pitch we are considering in development of the games, and the participants actually wear those sensors and goggles when they develop the games. And I hope you are seeing many of the games in which the participant is moving here and there, and according to the movement the second participant respond. So that is basically possible due to all these things. And you can see here that I've taken one picture where all body movements are possible. So hand is available, so shoulder movement, elbow movement, wrist movement, finger movement, all are possible. So these possible movements are actually tracked by sensors and the devices attached to their these arms, and accordingly on the software part, on the video part, what you are seeing is the object's information, the movement information, what being collected using those sensors. So degree of freedom actually being used over here to find the possible way in which an object can move. So you can understand from here that if we take out the molecule example, monoatomic molecule is here. So N is 1 only, so one particle is available, so degree of freedom will be 3 on the translational movement, and rotational and vibrational movement will not be there. So then if a diatomic molecule is there, so there will be 2 particles and the degree of freedom will be 6. So 3 translational, 2 rotational, and 1 vibrational degree of freedom will be available. Triatomic linear is available, so 3 particles and 9 degree of freedoms, 3 translational, 2 rotational, and 4 vibrational. And if we are having a triatomic non-linear, again it is 3, but translational, rotational, and 3 vibrationals are available. So this way we can calculate and we can find the degree of freedom. So in my next class, we will be having further discussions and few numericals how to calculate degree of freedoms. So I hope all of you can now find a way that degree of freedom are actually playing an important role in the development of the software games also, and anywhere the animation is taking place. Thank you. Thanks a lot.